Let's once again evaluate an integral using the technique of u substitution. So here's a definite integral from 0 to pi. The function is 1 minus sine squared of 3 theta. And then there's a differential here, d theta. So first of all, make sure you have great knowledge of your trig identities. If you react to this, you're going to realize this is just 0 to pi, the integral from 0 to pi of cosine squared 3 theta. Now, instinctively, you'll probably let u equal 3 theta. And if we do that, we'll see that du is now equal to 3 times the differential d theta. Now notice we don't have 3 d theta. In fact, what we could do is just solve for d theta. If we solve for d theta, notice 3 is not 0, so we could definitely divide by 3 on this equation. 1/3 du is now equal to d theta. Just make sure you never divide by a variable when you're performing your u subs. So we got 1/3 du. And let's see what this looks like. Wait, hang on. We have thetas, and our thetas need to be converted to u's. So why don't we do that? Why don't we find u1 of 0. So what would u sub 1 be? It's going to be equal to 3 times 0. And of course, that's 0. And let's find u2 of pi. And that's going to be what? 3 times pi. And of course, that is going to be 3 pi. We're ready to make our u substitution. So now the integral is from 0 to 3 pi. u1 is 0 and u2 is 3 pi. And we have cosine squared u du. But I'm missing something. I'm missing a 1/3. Let's put it all the way to the front of the integral. Now this is looking really good, because now we could just substitute another trig identity. This is just 1/2 1 plus cosine 2u du. So we're ready to integrate. 1/6 goes out to the front, and now we have left with what? U, let's see here, plus 1/2 sine of 2u. Yeah. Evaluate it from 0 to 3 pi. 2u right there. Let's keep on evaluating. Let's write it over here, because it seems like I'm starting to run out of room, but make sure you keep things neat. So 3 pi plus the sine of 1/2 times the sine of 6 pi, but that's 0. Sine of 6 pi is 0. And then minus 0 plus 0. That's really nice. And we are left with 1/2 of pi. And there you go. That's an evaluation of a definite integral using the technique called u sub.